Hey YouTube, just making a quick video on how to integrate a Wi-Fi module into your Raspberry Pi. The problem with the Raspberry Pi is it does not have built-in Wi-Fi, so you have to have a huge dongle sticking out of the back of it like that. Some of the other development boards have Wi-Fi built into them, which is nice and makes your project look really clean. So today I'm going to show you how to integrate this into this so it looks like one product. Some of the things that you're going to need here are a multimeter, a soldering iron, of course. I'm just using a butane one, a couple of drill bits, a drill. I'm going to extend the RP SMA connector from this out to the side of the box, so I have an RP SMA connector with a small coax coming off the back of it. Got that off of Amazon from some Chinese retailer for about £2. And a pair of wire strippers. Have a little bit of jumper wire here that I'm going to trim and use, and that should be all you need. Okay, first off we're going to take apart the USB dongle. This is just a TPlink TLWN722N. It's wireless N connector. So I'm just going to use this pry tool to slide under here. There's a couple of clips on the sides, and once you get under there, it's fairly easy to pop apart. Just run it along the edge, twisting it just slightly. Be careful not to go too far in because you could damage these surface mount components. So once it's apart, you can have something that looks like that. You can just set the trashy exterior aside, and the first step to this is removing the USB connector here. So I don't have any solder braid or any solder suckers or anything, so I'm just going to lightly pry up at the base of this connector while I heat the solder pads from below. So I'm just going to go ahead and do that. This might take a second. If you're using a better soldering iron than I am, then that's great. However, I'm using this butane soldering iron. They're mostly for like portability and whatnot, but they do disperse a lot of heat. So if you are using a butane soldering iron, be very careful that you're not getting too close to these IC chips, because the heat that blasts out the sides of these things will damage these IC chips and your USB dongle will stop working. Okay, so got that desoldered. Took a little bit of effort, and I wish that I had better tools, and if I could do this again, I would definitely have a pair of like modeling diagonal cutters, which I would have used to clip off the leads first before removing them. But I don't have those, so I just had to do what I could to get that out, and there it is. It looks all right. So at this point, what we're going to do is take a look at the Raspberry Pi here. So I'm going to go ahead and pop this case open. I got this case off of Amazon. I believe it's a pretty standard case. Kind of tricky to get open sometimes. Okay, so the Raspberry Pi B Plus here, and what we're going to be doing is choosing a USB port that we want dedicated to this Wi-Fi controller, and we're going to make sure that we have all the pins correct. So what we're going to do is just check to see which one of these USB ports connects to these pins on the bottom of the board. I'm assuming that by looking at this, I'm assuming that this back set of 4 pins here probably goes to the top port, and the top set of 4 pins goes to the bottom port, just by ergonomics. But we will test anyway, just to make sure. So I'm going to set my multimeter to continuity. I do happen to have a spare piece of USB cable, which is going to make this easy. So I'm going to use this spare USB cable to check for continuity between the pins and the port. Just chopped off the end of the USB cable there, the end that would normally go into your device. I'm going to strip back some of that, exposing some of our pins here. So do remember that once you're done with this modification, you will be losing one of your USB ports on the Raspberry Pi. So once you're finished with this modification, don't plug anything into the port that you've chosen to connect the module to. I'm not sure exactly what would happen if you had 2 devices connected to the same USB port, but I would advise that you don't try that. Okay, so I have a USB cable here, and I've stripped the end of it off. This is just going to help us check for continuity between the port and the pins on the back of the Raspberry Pi. You could probably do this a different way with the continuity tester, just by shoving it in there, but I thought that this would be easy because it would show us which colors were which without me having to look at a diagram of how a USB port is set up. So I'll just go ahead and plug this in. I'm going to choose the bottom port. So I'll just plug it into the bottom port, and I will test between continuity between these conductors and the pins on the board. I'll start with the 5-volt positive. So what I'm going to do here is tin up the ends of these and get them ready to solder onto this board. I'm just going to leave the existing connection there if I want to reverse whatever I did, and then just dab them together and apply a little bit of heat, and hopefully it should all stay together. Okay, so I've routed the cables around the edge here, just neatly under the bottom, and then they pop up right here next to the GPIO. I was able to do that pretty easily, and there was a lot of space under there, or just enough for the cables. You can see right here the board is flush with the case, so it's not binding against those cables at all. And those should neatly fit right up through the slot here for the GPIO. And we will lower this down, snap together. And there we go, USB on the inside. Now, I wish that I had some pin headers on me, so that way I could make this mod removable, which I will end up doing. However, right now I don't have any pin headers, so I'm just going to make it permanent, and then once I get some, I'll undo this and then redo it. It shouldn't take very long now that I've all... the hardest part really is just removing this USB port off of the module here. So I'm going to strip back a little bit of this and solder it onto here, and we can drop that in there, just like that. Okay, skipped ahead a little bit, but here it is complete. All I did was removed the RPSMA connector where the antenna used to connect to on the Wi-Fi module, and I added this little pigtail here that goes to the RPSMA that I mounted on the outside. I thought this was a good place for it because it didn't interfere with the GPIO, and I used, it's a little bit larger than 6 millimeters, so I had to kind of just use a drill to waller it out slightly, and then fastened this down and connected it to the board there. The center feed goes to exactly where the center feed from the old RPSMA went to, and in the ground plane I just use the shielding on this coax to connect to where the other RPSMA connected to this ground plane. If I was to do this again, I would probably just leave the old RPSMA on there and then just solder on to it rather than trying to remove it first, because removing it was very difficult, especially without solder braid or anything to remove the solder, because it does connect on the bottom side and the top side, so it was difficult to heat up all the solder to get it removed. You could probably use a Dremel tool, but if you just left the connector on there and soldered onto it, it probably wouldn't make a difference. So it turned out pretty cleanly here. I guess, like I said, if I was going to do this again, I probably would have used pin headers so that way I could remove it, but it was actually pretty easy to disassemble and put back together, so it makes no difference. I think it looks alright. Here it is all together. And, attach the antenna here just to see what that looks like, and tighten it down, and there you go. Raspberry Pi with built-in Wi-Fi. Thanks for watching.